Section 1.2, Integers. Learning Objectives. By the end of this section, you will be able to 1. Simplify expressions with absolute value. 2. Add and subtract integers. 3. Multiply and divide integers. 4. Simplify expressions with integers. 5. Evaluate variable expressions with integers. 6. Translate phrases to expressions with integers. 7. Use integers in applications. Be prepared 1.2. A more thorough introduction to the topics covered in this section can be found in the Elementary Algebra 2E, Chapter, Foundations. 1.2.1. Simplify expressions with absolute value. A negative number is a number less than 0. The negative numbers are to the left of 0 on the number line. See Figure 1.2. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Negative numbers. 0. Positive numbers. Figure 1.2. The number line shows the location of positive and negative numbers. You may have noticed that, on the number line, the negative numbers are a mirror image of the positive numbers, with 0 in the middle. Because the numbers 2 and negative 2 are the same distance from 0, each one is called the opposite of the other. The opposite of 2 is negative 2, and the opposite of negative 2 is 2. Opposite. The opposite of a number is the number that is the same distance from 0 on the number line but on the opposite side of 0. Figure 1.3 illustrates the definition. Figure 1.3. The opposite of 3 is negative 3. B. Opposite notation. Negative a means the opposite of the number a. The notation, negative a, is read as the opposite of a. We saw that numbers such as 3 and negative 3 are opposites because they are the same distance from 0 on the number line. They are both 3 units from 0. The distance between 0 and any number on the number line is called the absolute value of that number. C. Absolute value. The absolute value of a number is its distance from 0 on the number line. The absolute value of a number n is written as the absolute value of n, and the absolute value of n is greater than or equals 0 for all numbers. Absolute values are always greater than or equal to 0. For example, negative 5 is 5 units away from 0, so the absolute value of negative 5 equals 5. 5 is 5 units away from 0, so the absolute value of 5 equals 5. Figure 1.4 illustrates this idea. Figure 1.4. The numbers 5 and negative 5 are 5 units away from 0. The absolute value of a number is never negative because distance cannot be negative. The only number with absolute value equal to 0 is the number 0 itself because the distance from 0 to 0 on the number line is 0 units. In the next example, we'll order expressions with absolute values. Example 1.12. Fill in, less than, greater than, or equals, for each of the following pairs of numbers. A. The absolute value of negative 5, low line, negative, the absolute value of negative 5. B. 8, low line, negative, the absolute value of negative 8. C. Negative 9, low line, negative, the absolute value of negative 9. D. Negative, open parenthesis, negative 16, closed parenthesis, low line, the absolute value of negative 16. Solution. A. The absolute value of negative 5, low line, negative, the absolute value of negative 5. Simplify. 5, low line, negative 5. Order. 5 is greater than, negative 5. The absolute value of negative 5 is greater than, negative, the absolute value of negative 5. B. 8, low line, negative, the absolute value of negative 8. Simplify. 8, low line, negative, 8. Order. 8 greater than, negative 8. 8 greater than, negative, the absolute value of negative 8. C. Negative 9, low line, negative, the absolute value of negative 9. Simplify. Negative 9, low line, negative 9. Order. Negative 9 equals, negative 9. Negative 9 equals, negative, the absolute value of negative 9. D. Negative, open parenthesis, negative 16, closed parenthesis, low line, the absolute value of negative 16. Simplify. 16, low line, 16. Order. 16 equals 16. Negative, open parenthesis, negative 16, closed parenthesis, equals, the absolute value of negative 16. Try at 1.23. Fill in, less than, greater than, or, equals, for each of the following pairs of numbers. A. Negative 9, low line, negative, the absolute value of negative 9. B. 2, low line, negative, the absolute value of negative 2. C. Negative 8, low line, the absolute value of negative 8. D. Negative, open parenthesis, negative 9, closed parenthesis, low line, the absolute value of negative 9. Try at 1.24. Fill in, less than, greater than, or, equals, for each of the following pairs of numbers. A. 7, low line, negative, the absolute value of negative 7. B. Negative, open parenthesis, negative 10, closed parenthesis, low line, the absolute value of negative 10. C. The absolute value of negative 4, low line, negative, the absolute value of negative 4. D. Negative 1, low line, the absolute value of negative 1. We now add absolute value bars to our list of grouping symbols. When we use the order of operations, first we simplify inside the absolute value bars as much as possible, then we take the absolute value of the resulting number. D. Grouping symbols. Parentheses. Brackets. Braces. Absolute value. In the next example, we simplify the expressions inside absolute value bars first just as we do with parentheses. Example 1.13. Simplify. 24 minus the absolute value of 19 minus 3 times open parenthesis 6 minus 2 closed parenthesis. Solution. 24 minus the absolute value of 19 minus 3 times open parenthesis 6 minus 2 closed parenthesis. Work inside parentheses first. Subtract 2 from 6. 24 minus the absolute value of 19 minus 3 times open parenthesis 4 closed parenthesis. Multiply 3 times open parenthesis 4 closed parenthesis. 24 minus the absolute value of 19 minus 12. Subtract inside the absolute value bars. 24 minus the absolute value of 7. Take the absolute value. 24 minus 7. Subtract 17. Try at 1.25. Simplify. 19 minus the absolute value of 11 minus 4 times open parenthesis 3 minus 1 closed parenthesis. Try at 1.26. Simplify. 9 minus the absolute value of 8 minus 4 times open parenthesis 7 minus 5 closed parenthesis. 1.2.2. Add and subtract integers. So far, we have only used the counting numbers and the whole numbers. Counting numbers 1, 2, 3, dot, dot, dot. Whole numbers 0, 1, 2, 3, dot, dot, dot. Our work with opposites gives us a way to define the integers. The whole numbers and their opposites are called the integers. The integers are the numbers. Dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Integers. The whole numbers and their opposites are called the integers. The integers are the numbers. Dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Most students are comfortable with the addition and subtraction facts for positive numbers. But doing addition or subtraction with both positive and negative numbers may be more challenging. We will use two color counters to model addition and subtraction of negatives so that you can visualize the procedures instead of memorizing the rules. We let one color, blue, represent positive. The other color, red, will represent the negatives. Positive, blue, negative, red. If we have one positive counter and one negative counter, the value of the pair is 0. They form a neutral pair. The value of this neutral pair is 0. 1 plus -1 equals 0. We will use the counters to show how to add. 5 plus 3. -5 plus, open parenthesis, -3, closed parenthesis. -5 plus 3. 5 plus, open parenthesis, -3, closed parenthesis. The first example, 5 plus 3, adds 5 positives and 3 positives, both positives. The second example, -5 plus, open parenthesis, -3, closed parenthesis, adds 5 negatives and 3 negatives, both negatives. When the signs are the same, the counters are all the same color, and so we add them. In each case we get 8, either 8 positives or 8 negatives. 5 plus 3. 8 positives. 5 plus 3 equals 8. -5 plus, open parenthesis, -3, closed parenthesis. 8 negatives. -5 plus, open parenthesis, -3, closed parenthesis, equals -8. So what happens when the signs are different? Let's add -5 plus 3. And 5 plus, open parenthesis, -3, closed parenthesis. When we use counters to model addition of positive and negative integers, it is easy to see whether there are more positive or more negative counters. So we know whether the sum will be positive or negative. -5 plus 3. More negatives, the sum is negative. -5 plus 3 equals -2. 5 plus, open parenthesis, -3, closed parenthesis. More positives, the sum is positive. 5 plus, open parenthesis, -3, closed parenthesis, equals 2. Example 1.14. Add A. -1 plus, open parenthesis, -4, closed parenthesis. B. -1 plus 5. C. 1 plus, open parenthesis, -5, closed parenthesis. Solution. A. -1 plus, open parenthesis, -4, closed parenthesis. 1 negative plus 4 negatives is 5 negatives. Equals -5. B. -1 plus 5. There are more positives, so the sum is positive. Equals 4. C. 1 plus, open parenthesis, -5, closed parenthesis. There are more negatives, so the sum is negative. Equals -4. Try at 1.27. Add A. -2 plus, open parenthesis, -4, closed parenthesis. B. Negative 2 plus 4. C. 2 plus, open parenthesis, negative 4, closed parenthesis. Try at 1.28. Add A. Negative 2 plus, open parenthesis, negative 5, closed parenthesis. B. Negative 2 plus 5. C. 2 plus, open parenthesis, negative 5, closed parenthesis. We will continue to use counters to model the subtraction. Perhaps when you were younger, you read 5 minus 3 as 5 take away 3. When you use counters, you can think of subtraction the same way. We will use the counters to show to subtract. 5 minus 3. Negative 5 minus, open parenthesis, negative 3, closed parenthesis. Negative 5 minus 3. 5 minus, open parenthesis, negative 3, closed parenthesis. The first example, 5 minus 3, we subtract 3 positives from 5 positives and end up with 2 positives. In the second example, negative 5 minus, open parenthesis, negative 3, closed parenthesis, we subtract 3 negatives from 5 negatives and end up with 2 negatives. Each example used counters of only one color, and the takeaway model of subtraction was easy to apply. 5 minus 3 equals 2. Negative 5 minus, open parenthesis, negative 3, closed parenthesis, equals negative 2. What happens when we have to subtract one positive and one negative number? We'll need to use both blue and red counters as well as some neutral pairs. If we don't have the number of counters needed to take away, we add neutral pairs. Adding a neutral pair does not change the value. It is like changing quarters to nickels. The value is the same, but it looks different. Let's look at negative 5 minus 3 and 5 minus, open parenthesis, negative 3, closed parenthesis. Model the first number. We now add the needed neutral pairs. We remove the number of counters modeled by the second number. Count what is left. Negative 5 minus 3 equals negative 8. Negative 8. 5 minus, open parenthesis, negative 3, closed parenthesis, equals 8. 8. Example 1.15. Subtract A. 3 minus 1. B. Negative 3 minus, open parenthesis, negative 1, closed parenthesis. C. Negative 3 minus 1. D. 3 minus, open parenthesis, negative 1, closed parenthesis. Solution. A. 3 minus 1. Take one negative from 3 negatives and get 2 negatives positives, equals 2. B. Negative 3 minus, open parenthesis, negative 1, closed parenthesis. Take one positive from 3 negatives and get 2 negatives, equals negative 2. C. Negative 3 minus 1. Take one positive from the one added neutral pair, equals negative 4. D. 3 minus, open parenthesis, negative 1, closed parenthesis. Take one negative from the one added neutral pair, equals 4. Try at 1.29. Subtract A. 6 minus 4. B. Negative 6 minus, open parenthesis, negative 4, closed parenthesis. C. Negative 6 minus 4. D. 6 minus, open parenthesis, negative 4, closed parenthesis. Try at 1.30. Subtract A. 7 minus 4. B. Negative 7 minus, open parenthesis, negative 4, closed parenthesis. C. Negative 7 minus 4. D. 7 minus, open parenthesis, negative 4, closed parenthesis. Have you noticed that subtraction of signed numbers can be done by adding the opposite? In the last example, negative 3 minus 1 is the same as negative 3 plus, open parenthesis, negative 1, closed parenthesis, and 3 minus, open parenthesis, negative 1, closed parenthesis, is the same as 3 plus 1. You will often see this idea, the subtraction property, written as follows. B. Subtraction property. A minus B equals A plus, open parenthesis, negative B, closed parenthesis. Subtracting a number is the same as adding its opposite. Example 1.16. Simplify. A. 13 minus 8 and 13 plus, open parenthesis, negative 8, closed parenthesis. B. Negative 17 minus 9 and negative 17 plus, open parenthesis, negative 9, closed parenthesis. C. 9 minus, open parenthesis, negative 15, closed parenthesis, and 9 plus 15. D. Negative 7 minus, open parenthesis, negative 4, closed parenthesis, and negative 7 plus 4. Solution. A. 13 minus 8. Subtract. Equals 5. And 13 plus, open parenthesis, negative 8, closed parenthesis. Subtract. Equals 5. B. Negative 17 minus 9. Subtract. Equals negative 26. And negative 17 plus, open parenthesis, negative 9, closed parenthesis. Subtract. Equals negative 26. C. 9 minus, open parenthesis, negative 15, closed parenthesis. Subtract. Equals 24. And 9 plus 15. Subtract. Equals 24. D. Negative 7 minus, open parenthesis, negative 4, closed parenthesis. Subtract. Equals negative 3. And negative 7 plus 4. Subtract. Equals negative 3. Try at 1.31. Simplify. A. 21 minus 13 and 21 plus, open parenthesis, negative 13, closed parenthesis. B. Negative 11 minus 7 and negative 11 plus, open parenthesis, negative 7, closed parenthesis. C. 6 minus, open parenthesis, negative 13, closed parenthesis, and 6 plus 13. D. Negative 5 minus, open parenthesis, negative 1, closed parenthesis, and negative 5 plus 1. Try at 1.32. Simplify. A. 15 minus 7 and 15 plus, open parenthesis, negative 7, closed parenthesis. B. Negative 14 minus 8 and negative 14 plus, open parenthesis, negative 8, closed parenthesis. C. 4 minus, open parenthesis, negative 19, closed parenthesis, and 4 plus 19. D. Negative 4 minus, open parenthesis, negative 7, closed parenthesis, and negative 4 plus 7. What happens when there are more than 3 integers? We just use the order of operations as usual. Example 1.17. Simplify. 7 minus, open parenthesis, negative 4, minus 3, closed parenthesis, minus 9. Solution. 7 minus, open parenthesis, negative 4, minus 3, closed parenthesis, minus 9. Simplify inside the parentheses first. 7, minus, open parenthesis, negative 7, closed parenthesis, minus 9. Subtract left to right. 14, minus 9. Subtract 5. Try at 1.33. Simplify. 8, minus, open parenthesis, negative 3, minus 1, closed parenthesis, minus 9. Try at 1.34. Simplify. 12, minus, open parenthesis, negative 9, minus 6, closed parenthesis, minus 14.